This conference will now be recorded.
I'd like to welcome you to the first in our series of 8 webinars covering the unique aspects of networking for security applications. This is an educational series designed to provide the knowledge you need to understand why and how network design and the equipment it includes is different from what we consider to be standard networks. Standard networks are generally designed for small file formats such as Word and Excel, basically non-PoE requirements. Security applications require high bandwidth, high file packet size, and high PoE. These webinars are designed for all those involved in sales, support, and design processes. Many of you may find some parts of this too technical, others too basic. These webinars are designed for everyone, just as we are all involved in all parts of the sales process. The goal is a better understanding of network design and how it can reduce design time, increase reliability, reduce service calls, increase profitability by reducing after-sales service calls, resulting in overall more satisfied customers. Today's session is a network overview. The remaining 7 will focus on various aspects contained within the first one. So let's look at the topics that we're going to discuss today. The role of each component in the network system, the challenges facing IP CCTV systems. We're going to touch on PoE specifications and important factors. We're going to talk about fiber optics, recording as a network itself, and how we can make installation easier. So let's talk about the role of each component. What's important to understand is that every component within the system affects the others. So while we focus on the specifications that are usually of the connected devices, such as the camera, the recording device, or the viewing device, we often overlook the fact that their actual performance is dependent upon the network that they're transferred over. And that network contains many components. Regardless of the individual components, every one of them contains cable. And what we're going to do is to focus on the specifics of the cable and all of those differences involved within the cabling. There are many different types of cables that we can use within a system. And within each discipline of cable, there are many different factors that affect the transmission itself. Every part of the system matters. So regardless of what's placed between the components that are connected to the devices themselves, every single component within it will affect the performance of the system as a whole. Basically, when we talk about networking, we're focusing on 2 different areas, bandwidth and power. Bandwidth, basically, we look at in terms of resolution. Throughout the years, cameras have increased their megapixel resolution, and because of that, they've increased their associated packet size. As the need for more and more images per second and dual streaming increases, so does the need for higher bandwidth and the ability of the network to handle it. When it comes to power, we have a similar situation. When IP PoE cameras were first introduced, basically they performed at a very low PoE level. But through the years, as additional factors were increased in the system itself, such as day-night, PTZ, and other types of operations, the need for power also increased. When we look at the systems, we have to understand that they're based on performance by IEEE standards. And these standards dictate the length of the cable and the performance that's expected. When IEEE standards were first introduced for IP PoE operations, they were based on Cat5 cabling, a specific cable with specific performance, and how that performance operated over 100 meters, 328 feet. So it was looked at that if you had a certain power source at one end of the cable, you would result with a certain bandwidth and a certain amount of PoE at the other end of the cable. In this way, the cable was fixed, the type of cable was fixed with a known resistance to it, and the performance was fixed. However, within the PoE operation, there are many variables that affect its operation. PoE and the ability of factors within the system to recognize PoE and present the proper PoE is a complex process, but we're going to basically simplify it. If I take a camera out of a box, it's basically in an off condition. If I program PoE to the port of a switch and I try to measure it, it will measure 0. And that's because part of the IEEE standard says, until I have a complete circuit or a connection, I'm not going to transmit power, and this is for the protection of the connected devices. Once I take my Ethernet cable and plug it into both ends, the port of the switch and the camera itself, the first thing that happens is a voltage is generated. And this is sometimes referred to as the detection pulse. This voltage travels along the cable and goes to the camera, which in the IEEE standard is called the PD, or the powered devices. It's basically a fixed resistance. And the action of the voltage going across the resistance does two things. It returns a signal to the port of the switch, which in IEEE standards is called the PSE, the power source equipment. And it says I have a valid connection, and it says give me that much power. And if the port has the ability of providing that power, it flows and everything's normal. However, what you're seeing in the slide itself is all the parameters of what that signal has to travel through and the time duration. And most important is that detection time. And that detection time determines whether or not it has a valid connection. If it doesn't see a valid connection, the port shuts down its power. If it sees more power than the port is able to produce, it shuts down, thinking that it's in a short condition. So timing, the amount of power, and the amount of time it takes to process this all becomes important in establishing a good PoE connection. But we have a bunch of variables in this. There are various manufacturers of PD chips and PSE chips, and they all operate a little bit differently. You put them in a circuit where manufacturers design different circuits for cameras and everything else that's powered by PoE, and they all operate a little bit differently. And that's where the confusion starts coming in. Here's a chart of PoE and its various classes. And as you can see, there's a great deal of variation within these classes and the amount of power that it produces. But again, the source and the resulting power over 100 meters, 328 feet, is dictated by that use of Cat5 cabling. So for example, if in 802.3 AF, I have a source of 15.4 watts, sometimes referred to as class 3, when I travel that over a Cat5 cable for 100 meters, the resulting power at the camera will be 12.95 watts. But as you can see also, there's a great deal of variation in the voltage. Now in the previous slide, we talked about how important that voltage is. In a sense, it's the wake-up signal that turns on the camera. And it can be anywhere from a PSC output of 44 to 57 volts. And the PD input could receive anything from 37 to 57 volts. And you notice that first figure of 37 is lower than the 44 because it takes into account the resistance of the cable. In general, though, like anything else in electronics, as the cable distance increases, the cable resistance increases, and the voltage and the wattage that's available to the connected device is lowered. So as you can see here, when we look at the two different standards, one being 802.3 AF at 15.4 volts, when it travels along the cable, what's received at the camera is 12.95 watts. 30 watts is 802.3 AT, and when it travels along the cable at a distance of 100 meters, the resulting wattage is 25.5 watts. So this is what's taken into account when we deal with the standards. But here's a point that I want to emphasize. The standard was made only for Cat5 cabling. And yes, it's been carried over to CAD 5E, CAD 6, CAD 6A. But notice in every single definition, I've used the word CAD cabling. What we're going to learn and what you encounter in many of your applications are different types of cabling. For example, coax. Many applications now have or need existing coax, which has been in the walls and run for analog cameras for maybe 4 decades. And the goal is to transmit IPPoE over coax cabling without the expense and sometimes even health conditions that are required for inspections in hospitals and schools if you have to remove that coax. Coax is very different from CAD cabling. Other applications might include what we call single pair cabling. Single pair cabling mostly in alarm situations, and the requirement there would be to run IP or PoE over single pair cabling. Both of those, as an example, are not CAD cabling, and therefore they have different characteristics. More important, they were never included or involved in the standard itself. So each time when we look at a cable, we have to think of it in terms of the fact that it has to meet the requirements that were set for a different type of cable. So if I'm using single pair or if I'm using coax, they still have to meet the requirements of getting the signal from the PSE, the port of the switch, over to the connected device, the camera, operating properly and providing the correct amount of PoE. So when we look at this, what are those differences? Well, there's a lot of them. When we talk about CAD 5E or CAD 6, we're basically talking about a cabling that has 4 pairs of wires, 8 individual wires. And the bandwidth can be anywhere from 1G to 10G. It uses 2 of the pairs when we talk about PoE classes from 0 to 4, and 4 of the pairs for anything that is over that or over that standard, which is commonly referred to as 60 watts. And we'll cover the many other different terms in later segments. It can handle a total of 95 watts if both what's called the A and B pairs are used. And it can transmit IP video and PoE up to 3,000 feet. That is using Vigitron solutions. It also has a very high noise canceling factor. Now, when we talk about single pair, we're taking that and we're reducing it to 1 pair. So we're reducing the bandwidth. So once again, we have a limitation. Basically, a single pair can only carry 10 megabps, unless you're using Vigitron products, which can carry up to 100. The PoE is going to depend on the thickness of the wire. And here again, so even within a single category of products, such as single pair, we have many differences, such as 24.2, 22.2, 22, 18.2, 16.2, etc. And they're all going to have different transmission characteristics. IP video transmission is limited to about 1,700 feet. And because you don't have the twists involved, it's very susceptible to noise. And you can see these differences in the various gauges of the wire as we go down and their effect on resistance. Resistance is the main problem that we have when we're transmitting and trying to get both bandwidth and PoE from a source to drive a camera. Once again, what is the difference of CAD cabling or what we call flat cabling or untwisted cabling? Well, one of the reasons that CAD cabling was selected as to be the standard for IP PoE transmission is because its twists result in a lot of noise canceling. And by noise canceling, we open up the channel for more signal. When noise is on the line, it takes the place of signal and reduces the amount of signal and therefore the amount of distance that the signal can be carried. Fiber is unique in this. And the first thing we want to say about fiber is glass. Fiber is used because it rejects a lot of signals, because it rejects the ability of transmitting surges. And for all of these reasons, you cannot transmit PoE over fiber. It's not possible. In most cases, when we deal with a network, the instrument that we're using to transmit data over fiber and connect to individual devices uses what's called an SFP, a small format pluggable. And this device is very convenient because we can marry it, and it must be married to the fiber that it travels over, but it's just a matter of marrying it to the SFP itself. However, there's another problem. Unlike connections that use copper or Ethernet cables, which are basically standardized between all the devices that they connect to, even what you may find in your house as far as your connection, your cable connections, SFPs don't have standards. In fact, there's only one standard for SFPs that's called the MSA, or the multi-source agreement. And that only applies to the physical interface. The multi-source agreement only says I can take an SFP and I can plug it into the port of a switch, which most of them contain MSA connections. Other than that, there really isn't any interchange. So we're faced with the problems that sometimes SFPs will not be able to communicate with an individual switch. It may not be able to recognize the SFP, or it may not be able to recognize the bandwidth that it's transmitted on. And in many cases, when we operate our switches and set them up, we assume that by operating them in the auto bandwidth detection mode, which is commonly the mode that we operate in, it will automatically detect the bandwidth that's present on the line, setting the correct bandwidth and processing it. That's not the case with SFPs. And if it doesn't recognize the bandwidth, you may have to go in and actually fix the bandwidth of that port. Some SFPs contain what's called a DDMI, which is basically a digital interface that tells the switch what the characteristics of that SFP are. It's not contained in all SFPs. Again, there are no standards. But if it is contained in there, a convenient way of seeing if your SFP will interface with your switch is to plug the SFP into the switch and use the GUI of the switch to read the SFP. Again, don't assume that your switch will automatically detect the SFP. Okay? You may have to fix the port speed. The other factor that we overlook in our systems is the recording device as its own network. And it is. One of the common problems that we hear all the time for technical support, and we get many references from many manufacturers, even for systems that don't contain our products, and we're happy to help them out, is that it's not recording a camera, or it recorded a camera at one point and not another point, etc. Well, a recording device has its own bandwidth. Let's start at the beginning. We're taking a signal out of a network switch. Commonly, that uplink will be 1G, and we're plugging it into an NVR or a VMS system running on a computer. Typically, that input is going to be 1G, but that bandwidth itself has a limitation. That limitation of what it can handle is going to depend on many, many, many factors. One of them is going to be packet overhead, which we'll discuss in great detail. And basically, when we account packet overheads, we find out that the actual transmission bandwidth that we have is basically cut in half by the use of packet overheads. So when we talk about 100 megabps, we actually only have 50 megabps available for the transmission of a camera. When we talk about 1G, we're basically down to 500 megabps. Now, a single camera link to a switch port, 50 megabps is a lot. But when we talk about the number of cameras that have to be transmitted through a switch into a single port of an NVR or a VMS system, 500 megabps may not be a lot. when we consider the number of cameras and we consider the frame rate, the size of the packet, the size of the bandwidth that's required for each camera, etc. A lot of factors have to be taken into account. So quite often we find when we troubleshoot the system and we look at the output of just the switch itself, everything's fine. And what happens is there's too much of a signal, too much of a bandwidth going into the NVR. The NVR or the computer, similar types of processes, actually have many bandwidth ports. One we just spoke about, which is the input port itself and the amount of bandwidth. But that system is writing to a hard drive. That has a bandwidth limitation. In some cases, we're recording and we're viewing it. That has a bandwidth limitation. And all of these are compounding itself within the NVR or the VMS system itself, limiting the amount of overall bandwidth that the system can handle. We're going to be emphasizing throughout the series just how important everything within a network is, just how important it is because they all interact with each other. And by interacting with each other, it means that they all affect each other. And even a slight change within the system can lead to a total change in the entire network. Vigitron offers a free and without obligation design center service. And one of the reasons we do this is very, very simple. Too many times in the sales process, somebody will call up and say, I need an extender, I need a repeater, I need a PSE, a PoE power source, give me a part number. And the biggest mistake anybody can make is asking that question. And the biggest mistake a manufacturer can make is responding to that question. What you see here is a very important slide because it outlines all the questions you have to ask before you get to that answer about what part number do I need. We have to talk about the cameras. What's the manufacturer and the model number, because that will dictate the characteristics of the camera and how it has to be handled in terms of PoE. What's the number of cameras routed to a single network? Well, the more cameras, the more the bandwidth requirements, the more the PoE power. What type of cable are we using? And again, the type of cable we're using has an enormous effect on everything. What's the cable length? We already outlined the longer the cable distance, the higher the resistance itself. And what's the PoE source that we have? Is the PoE source we have adequate enough to drive the system? So these are all the things you have to take into consideration every time you ask about a network component within your system. Never, ever design a system without studying all the network component specifications, because they all have to be met by every single part of the system itself. And this is why Vigitron offers a free, without obligation design center service. And our design center service is based on over 9 years and a continuing effort by Vigitron of every year we do interoperational testing of major products in cameras, access control, LED lighting, audio products. And we do this not to test for the specifications of the products themselves, but to see what their requirements are and where the holes are, so that when we design our network equipment, it meets those requirements and can bring out the best performance of those connected devices. The service is free, it's without obligation, and most important, these are too complex to be used by a computer program or a drop-down menu. There is no cookie cutter approach to this. Every single system is unique. And because it's unique, we have a staff of engineers that will handle each of your requests to give you the most reliable and cost-effective design. So again, what are the advantages of dealing with Vigitron? Well, you can't really offer a total network design unless you have all the network products. And Vigitron has over 250 products in the IP PoE category, covering every single category of networking products. So we can give you a complete design. This also avoids finger pointing because you're getting one design from one source. Our products are designed, tested, and quality controlled in the United States, with service support again from skilled engineers. And because of all of this, we offer the industry's longest warranty, production lifetime plus 3 years. Now, what does that mean? Very simply, when a product does go end of life, you, your customers, are protected by a full 3-year warranty. No other manufacturer can offer this because we are the manufacturer of these products. So again, I'd like to thank you for participating in this first of a series of educational seminars. We hope that you'll continue to enjoy these, and in the future seminars, we're going to take each of the total aspects that we covered during this and dive into them in greater detail. So this is our contact information. If you have additional questions, need design support, or questions on anything about our products, you can email to support@vigitron.com. You can call us, or you can email me, Neil Heller, directly. Thank you again, and we look forward to hearing from you.